So let's look at some examples below here. So the first one is 5 times 2 root 3. So even though, or if your two expressions or two terms might not have both parts, like a root and a whole number, they still have like parts. So in this case, there might not be anything to multiply with that root 3, but you can still multiply the 5 times the 2. So 5 times 2 root 3 just becomes 10 root 3. And then you guys don't have anything to simplify because there's not going to be any perfect roots underneath that root there with the 3. So how about 2? Negative 3 root 2 times 6 root 5. Multiply the outside coefficients, multiply the roots together. So negative 3 times 16, negative 18. Root 10 times root 5, or I'm sorry, root 2 times root 5 is going to give you guys root 10 underneath there. And even if you don't know or you're not sure, you can always check to factor. Like I personally know that the square root of 10 is not going to be able to be simplified any further. But if you guys tried to factor it, it would just be a 5 and a 2, and there wouldn't be anything with a pair underneath there. So you couldn't simplify this any further. So how about 3? 2 root 8 times 3 root 3. So the outside's 2 times 3, 6. The inside's 8 times 3, 24. So 24, there's going to be some perfect squares in there. So this is one of the instances where once you've done the multiplication, you need to simplify or factor out 24. So 24 could be 12 and 2. 12 could be 3 and 4. Or 2 and 2. So remember, we don't really include anything that we branched out. So we're just looking at the end of the branches. So there's a pair here, and then these two guys are left without a match or a pair there. So what's going to happen is the 2 is going to come out here with this 6 and make that 12, and we're going to have 3 times 2 multiplied together underneath. So 12 root 6. Number 4, square root of 10 times 3 square root 8. So you can put a number 1, like a coefficient 1 out there in the front, but the number in the front is just going to stay 3. Square root of 10 times square root of 8 is going to become 80. 3 root 80. So we are definitely going to have to factor 80. So let's just start with 10 and 8. 8 can be 4 and 2. 4 is 2 and 2. And then 10 is 5 and 2. So looking at the ends of our branches, we have a pair and another pair. This 5 is by himself. So we're going to have 3 times 2 times 2 outside, 5 left. So this ends up being 3 times 2 is 4, or 3 times 2 is 6, 6 times 2 is 12. So this ends up being 12 root 5. So let's look at the division ones now. So 5 root 6 over 10 root 2. So remember, just like multiplying, with dividing, you're doing like parts. So we're going to see if we can reduce the coefficients in the front, then if we can reduce the roots. So 5 and 10 can both be divisible by 5. So if you divide both of those by 5, you get 1 on the top. 10 divided by 5 is 2 on the bottom. Then you guys want to see, okay, well, can you reduce 6 and 2? Yes, 6 and 2 you can divide by 2, and you technically get just 3. So we're just going to leave, because 6 divided by 2 equals 3. Since they were both under a root, it'll say root 3. And that's it. There's no root left in the denominator, and there shouldn't be, to make sure that this is completely simplified when you're doing division. So the square root of 24 divided by 3 times the square root of 4. So there's no number other than 1 out there in the front in your numerator, so this is just going to stay 1/3 or just 3. You can put the 1 there. But then the 24 divided by 4, or 24 over 4, is going to be 6. So it is going to still be under a root, but that's going to be in your numerator. (12√8) divided by √2. So we can do the 8 and the 2 and give us 4. So this would be 12 on the outside, square root 4. But this is the first case where you guys could simplify what's underneath the square root when dividing. So you can either factor it, or just know that the square root of 4 is 2. But if you factor it, that would be your pair that would come out. So 12 times 2, this actually ends up being just the value 24 without any radical or root left. And then your last one, number 8, √72 over √8. So this is a similar case because 72 divided by 8 is 9. It's still under that square root, but the square root of 9 is just 3. You could also factor it. Like if you factored it, you'd come up with just one group with nothing left, but it is a perfect square. So when you're multiplying and dividing, you just do the operations with the like parts, do the multiplication or do the dividing and reducing. You just have to check that after you've done that operation, if you can simplify what's underneath your root. If you can't simplify what's underneath the root part, then you guys would be done. So you just need to check at the end before you say, okay, that's my answer.